Hello students, we are going to continue our video for normal distribution. The question we are working on is on the Word document there. It states that IQ, or intelligent quotient, is normally distributed with a mean of 100 and a standard deviation of 15. What is the IQ that would indicate that someone is in the top 15% of the population? And then alternately we'll do the question, what is the IQ that would indicate that someone is in the bottom 30% of the population? Let's go into our whiteboard. Before we do that, key statements and terms in this question we know is normally distributed. The data IQ in this example is normally distributed. So what we can do is go to a bell curve. Let's do this in black. So we know that it follows a normal distribution of average of 100 and a standard deviation of 15. The question states that what is the value that would indicate that someone is in the top 10% of the population. Top 15% of the population, excuse me. So we're going to put that out right around there. There's 15%. Question like this is a backwards type question. So this area here is 15%. I'm going to put that as a decimal. Whereas normal distribution type questions give you the mean, the standard deviation. It gives you an x value and asks you to calculate the area that it is, or the probability that is more or less than that x value. So then we calculate a z value, we find the area, we make an adjustment to get our answer. This question, we already know the area. The area is 0.15, so this is one of those backwards type questions. One of the first things we need to do is calculate the area in this little section here. We know that the mean separates the distribution, cuts it in half. So the upper section of the distribution has 50% of the area, or 0.5. So this section here would be 0.35. 0.35 plus 0.15 would equal 0.5. What we want to do eventually is find an x value. First, though, we need to find that z value. The z value is based on that area of 0.35. In the charts that we have, we're going to look for an area of 0.35. So once again, remember that this is a backwards type question. Typically, you know the z value, which is down the first column here and across the top, and you look based on that z value, you look for an area, one of these values in here. These type of questions, though, we know the area. The area is 0.35, so it's one of these interior values, these areas or probabilities. What you want to do is find one that's closest to 0.35. You can tell that the areas, as we go across the top, increase, and as we go down, they increase as well. So these values are increasing kind of as we go down the table. So a value of 0.35 is going to be closest to that value. We're not worried about going over or being under. We're just looking for the one that's has the closest value to 0.35. So this area 0.3508 has a z value of 1.04. So now we know that the z value is 1.04. So we know that whatever the x value is going to correspond to that z value of 1.04. We put this into our formula, which we have as being z equals x minus the average over the standard deviation. Z is 1.04, x is our unknown, the average is 100, standard deviation is 15. Kind of doing some cross multiplying there, we would get an X value of approximately 115.6. So that is the answer. Anybody or any value, IQ value greater than 115.6 would be in the top 15%. So let's go and tackle the second question we have here. What is the IQ that would indicate that someone is in the bottom 30% of the population? This question is going to start out the same way. Let me just clean my slate here. Go back to black. So we're going to draw out this normal distribution. It has an average of 100 and has a standard deviation of 15. What we want to know is the probability, not the probability, but we want to look for that X value that would indicate that someone is in the bottom 30% of the population. So the bottom 30% is going to be in this section here. So we're going to shade in that. This corresponds to 30%, or 0.5. So if that value is 0.35, we know that this value in here will be 0.2, or 20%. It's that middle value that we use based on the charts that we use for normal distribution that indicate what the appropriate Z value is. And then from the Z we can find the X value. So Z being unknown, X being unknown. So similar to the first question that we did, we take that area of 0.2 and we go into our chart and we're going to try to find the closest Z value that corresponds to an area 0.2. These ones here are close. This one is slightly closer than 0.2019, so we're going to use a Z value of 0.52. So Z value 0.52. However, you have to, when you draw this out, and because the question states it's in the bottom 30%, when we draw this out, we know that we are on the left side of the distribution, which means we are less than average, which would also indicate that the Z value is going to be negative. If you forgot that the Z value was negative, you're going to get a value indicating that the X value is somewhere up there. So let's put this into our formula, which is, once again, right there. We know that the Z value is negative 0.52. The X's are unknown, we're trying to solve. Cross multiplying that, remembering that the Z value is negative 0.52, we're going to get an answer, an X value of 92.2. So someone with an IQ less than 92 would be in the bottom 30% of the population, which would be indicated right there.